In this lesson, we are going to start working with system story problems. So you'll see that we have 3 that we're going to do with this lesson. The first thing we want to do is learn to read story problems and try to write equations or inequalities out of them. These problems we're going to do are all going to be equations. Generally in story problems, each sentence is an equation. So as you'll see, I kind of color-coded these. But this one, the first sentence says one number is 3 more than twice another. There's one sentence, so that is probably one equation. Doesn't always work, but that's something you could start with to kind of get you started on how to write the problem. So if we start with that one number is. Break it down into pieces as you write it. So one number. They don't tell us what that number is, so we're going to probably call it a variable, right? So I'm going to say x. One number is. What does is mean in math? Is equals. So one number is 3 more than. So 3 more than would be adding, twice another, meaning another number. So I'm going to take 2 times that other number because it says twice another. So I'll take 2 times, and I have to pick a different variable because they said another. So 2 times y. So now look at the sentence. Look at my equation as I read it to you again. One number is 3 more than twice another. If you have a hard time writing these, breaking it down, doing a couple words at a time is really going to help you. Then I look at the second sentence. It says their sum. Well, who's they? They are the numbers. They are x and y. Their sum is 24. So their sum, x and y's sum, meaning we're going to add them, their sum is equals 24. Writing them is going to be the part that you have a hard time with probably, and that's what we want to work on. We want to get better at taking values and data and ideas out of word problems. They aren't as scary as they look. We want to try and find ways to make them easier for us to write. So we're starting with some easier ones. And here's my 2 equations now. So when I get to this point, I solve either using substitution or elimination. Since this one already has an x by itself, I would probably choose substitution. If you want to put that top equation in standard form, you feel free to choose elimination. There's no right or wrong way to get it. But I'm going to go ahead and substitute here to solve this. So 3 plus 3y equals 24. I subtract 3 from both sides. So 3y equals 21. Divide by 3, so y equals 7. Once I find that y is 7, I'm going to go ahead and substitute that right here in that circled equation. So I would have x equals 3 plus 2 times 7, which x equals 3 plus 14 then, so x is 17. We don't actually write these answers as ordered pairs because we actually know what we're talking about. We're talking about 2 different numbers. There's no reason the 7 or 17 should come first. We aren't looking at a graph. We're talking about which 2 numbers work. So you may answer in either order, and you would say the numbers are 7 and 17 because they asked for the 2 numbers and we just gave it to them. So that's kind of a nice start to it. With any word problem, if you can find a way to do it other than how I'm showing you, that is fine. There is more than one way to solve a problem, and when you are an adult and you are doing problem solving, you will have different ways. And you should be creative in how you do that. Any way you can come up with an answer is great. I'm just showing you one way that works and it kind of matches what we're studying. Our second problem, I think, is our most difficult. And so we're going to take a little bit of time on this one. But if we read it together, again, remember, a sentence is an equation normally, right? So it says the sum of the digits of a 2-digit number is 11. So the sum of the digits of a 2, so I'm just thinking in my head right now, okay, a 2-digit number is like the number 23. Well, if I add their digits, 2 plus 3 is 5. So they're saying whatever our number is, when you add its digits, it equals 11. So off the top of my head, I'd say, well, what numbers add to make 11? 1 and 11, or 1 plus 10. How about we add 1 plus 10, 2 plus 9, 3 plus 8. See the hang of it here? So numbers that would work for me, that's not going to make a 2-digit number, but like 29 is one of those numbers, 38 is one of those numbers, 4 plus 7, so 47 could be one of those numbers. So we have a list of numbers. We can go all the way up to the ones that add to 11, and that's a list of numbers that are going to work for this problem. So I'm just kind of getting my brain in the right way of thinking of what they're talking about here. Then it says if their digits are reversed, the new number is 9 more than the original. So if I reverse these digits, look at this. 92. Is that 9 more than the original? Well, no. That's way more than the original, right? I can see that it's not 9. So that's out. If I reverse these digits, 83, is that 9 more? So you can solve this by kind of guessing and checking and playing around with numbers, and that's good thinking skills. There's nothing wrong with that. I think that's a valid way to solve this problem because you're thinking through it, and maybe you don't have to write it down like I am here. Maybe you're doing this in your head, which is good thinking in your head. So that's a way you could solve it right now. I'm going to also show you a way mathematically. So if this was, let's say, numbers we couldn't think of, or they were all decimals and it was a pain to list all of them, or whatever the reason, we want to also come up with a way that we could list it mathematically. And again, I don't care which way you end up choosing to do. So here's how I set up my problem. I first am saying, okay, how am I going to call this original number? I could just call it x, except that it has 2 digits. So I have to have something in this digit spot and this one. So I'm actually going to call my original number initially xy. X being this tens digit, so in the tens place, and y being this ones digit, so in the ones place. And I have to represent each digit, because think of the numbers I had over here before, like one example was 29, right? This is the 2 and this is the 9. I can't just call 29x, because eventually I'm going to have to reverse these digits. So see how this would be my x and my y? When I reverse them and I had the 92, now I'm going to have a y and an x. So I need to separate those digits so I can reverse them later. So now when I'm thinking of place value, that plays an important part here, because looking back at this 29 here, this 2 isn't really a 2, is it? What does it represent? That x is a 20. And then the y is a 9, so that's where I get the number 29. If I had the x be a 2, we would think of it in the ones place. So this is my actual x value, it's a 20, and my actual y value is a 9. So when I bring that back over thinking with my variables, the left side here, I'm going to say this x, since it's in the tens place, is actually really valued at 10x. Because whatever number goes there, I'd have to take times 10, it's in the tens place, and its value would really be that. So let's think of some more numbers. 92 was one of the numbers we had, right? 90 is what I said. So it's not 92, it's 92. I need to take that 9 times 10 to get the true value. So I'm actually going to say that to find my number, I would have to take 10 times the x. So in this case, look at the 9. 10 times 9 would be 90. And then I have to add the y to it, which is a kind of a tough concept for you guys to probably understand. So what I want you to do right now is think about any number I could put in here. And let's not even worry about it adding to 11. Let's just pick a whole bunch of numbers. 27, 36, 48, 52. Okay, there's some random numbers I picked. In order for this to work, for me to represent these numbers using variables, think of me plugging it into this formula. Would I get the number? 10 times 2, because that's my x, right? Plus 7. Does that make 27? Yes. 10 times 3. Plus 6. Does that make 36? 10 times 4 plus 8. So that's where that 10 is coming from. I need to represent that place value so it ends up being 20 or 30 or 40 or 50, not 2, 3, 4, and 5. Hopefully that makes sense to you. If not, we can clear that up tomorrow too. But it is kind of a new concept for a lot of you. So there's my original number. I'm going to use 10x plus y to represent my original number. My original number where the sum of the digits add up to 11. So now I'm going to say my new number, so the one when I flip it. That's what I'm looking at next, is the number I flip. So my new number I would say my new number, I'd have to flip it. So in these spots here, I'd have a y and then an x. So now my y happens to be in my tens place, and my x happens to be in my ones place. So think of how I did that before. This would be written then as 10y plus x. And that's what happens when I'm flipping that number. So I want to be able to represent both. So now I have to actually write these equations. The first one's not too bad, so let's read the blue one again. It says the sum of the digits of a 2-digit number is 11. Well, I have the digits, don't I? I called them x and y. So I would say x plus y equals 11. Since I've already established that my digits are x and y. Whichever one I use, they're both x and y. Then the second sentence says, if their digits are reversed. So if their digits are reversed, well, isn't that this right here? I did that there, didn't I? So I'm going to say if their digits are reversed. Okay, let's use that. If their digits are reversed, the new number is. So is 9 more than the original? 9 more than, and where's my original? Right there. 9 more than 10x plus y. So take a look at that. 9 more than 10x plus y. So now I have my two equations. I can choose to solve this with whatever method I want to use. Let's say we go ahead and try standard, putting them in standard form and solving. So I'm going to take my bottom blue equation, and I'm going to get the x's and y's on the same side. So I had minus y and minus 10x. So I'm going to put my x's first. I hope you're okay with that. Negative 9x plus 9y equals 9. And then I'm going to bring down my equation I had before. So now I need to, if I want to put this in, I have them both in standard form, I want to use elimination. I'm going to go ahead and try to eliminate either my x's or my y's. So let's just do the x's. Okay? I times this by negative 9, or excuse me, positive 9. So I'm going to copy my top equation the same. And then my bottom equation I have 9x plus 9y equals 99. So now when I add here, I get 18y equals 99 plus 9 would be 108. Divide both sides by 18. So what do you think 108 divided by 18 is? I'm going to go with 6. How's that sound? If you're not sure, you always can check your work. Oh, look, I did it. Okay, so I found y to be 6. Meaning, in my original number now, this is what I'm finding. My original number that I wrote here, and my reverse number, that means my first digit for this one in the y spot is 6, and that means this one's a 6. Because I just found y. So now to find x, it's pretty easy because I know x plus y equals 11, right? So now that I know that y is 6, x plus 6 equals 11, so then x must be 5. And let's check that. If I actually put a 5 in those spots, I get the numbers 56 and 65 as my two numbers. Does that actually satisfy what they're asking us? So the first thing said the sum of the digits is 11. 5 plus 6 is 11, right? Both ways, so it works. If you reverse the digits of the original number, so that this is the original, if I reverse the digits and get 65, is that 9 more? Am I adding 9 here? And I am. 56 plus 9 is 65. So what I just showed you is a kind of complicated way to make that happen. If you looked at the first way I did it and I kind of did it guess and check and did it in my head, that's okay to do it that way. But I also wanted to show you algebraically how you could get this answer, because I think that's important too. And so you can choose which way you do it, but I know some of you might be interested in solving it this way. So I would then write my answers to say, get myself some room here. The original number is 56, and the new number is 65. And that's it. Our last one then is going to feel like quite a break after that second one. When I stand on top of the high school, our combined height is 24 feet, meaning me and the high school. The building is 3 times as high as I am. What is my height? So I might draw a picture for this. Here's the high school. And here's me standing on top of the high school. Dancing, apparently. You can draw yourself. I'm going to make myself dancing. There we go. So now they told me when I stand on top of the high school, our combined height is 24 feet. So if I'm using my picture, I'm saying from here to here is 24. And then it says the building is 3 times as high as I am. So that means that I could maybe separate this into quarters, right, if it's 3 times as high. Or you can draw that in your picture however you want. I'm going to say I would just put in my picture, this is 3 times higher, and I'd go with this area. Okay? If some of you already know this answer in your head, that's fine. Write the answer and you're done. If you want a way to solve it, I'm going to say that if the building is 3 times as high as I am, that means that I'm the original height. I'm x here. And this building height is 3 times me. So if I add my height plus the building's height, which is 3 times my height, so that's why it says 3 times x, it should equal 24. So when I solve this here, I find that x equals 6, and that's feet. It's important to remember what x is representing, though. X is representing me. Is it asking for my height? Look at the question. It is. It's asking for my height. So the answer is my height is 6 feet. That's my answer. One thing you want to really watch is what they're asking for. Make sure you answer the question. Because what if they would have said, what's the height of the high school? The answer wouldn't have been 6 feet. I would have had to take my answer times 3, and I would have had to say the high school is 18 feet tall. So make sure you're answering the question. That's where a lot of students get messed up on their objectives.